The symmetry of the standard normal distribution allows us to observe things like the empirical rule. The empirical rule says that if you're within one standard deviation of the mean, so between z-1 and z-1, that contains 68% of our data. If we're within two standard deviations of the mean, so between -2 and +2, we completely cover up that 68% of the data and add additional area, so that would make up 95% of our data. And if we go one standard deviation further, we're within 3 standard deviations. This makes up 99.7% of the data. It's not 100% of the data. There's a tiny bit that's unaccounted for, and if you look very closely to the left of -3, the tail is not colored in. To the right of +3, the tail is not colored in. There's only 0.3% of all the data that's not represented by within 3 standard deviations. Most of our data lives within 3 standard deviations, but there might be an outlier that lives outside. And similar to an outlier in a box plot, we can determine that a data value is an outlier by saying, no, if it's more than 3 standard deviations away from the mean, that's an unusual value. We can use these ideas to find other areas, not just the center 68%, the center 95%, the center 99.7%. In fact, we can use this empirical rule to find the shaded portion within 1 standard deviation above the mean. We can think about the center 68% of data within 1 standard deviation of the mean and recognize that we're looking at half of that data. So taking the 68%, cutting it in half, we find 34%. So between z=0 and z=1, we're looking at 34% of the data. What about between z=-2 and z=-1? We can use a similar trick to find that area. Notice that that is the additional part on the orange curve, so outside of the yellow but still on the orange, but it's only half of it. So what we're going to do is take the yellow away from the orange, so 95% minus the 68%, and then cut it in half. So 27 divided by 2, that area from z=-2 to z=-1 is 13.5%. Let's try one more. Between z=2 and z=3, can we find that area? We're going to have to use the blue area this time. So we'll start with all of the blue area and we'll take away all of the inner orange area. So if we do 99.7 minus 95, we get 4.7, but that needs to be split amongst the 2 tails on the blue curve, so we can cut that in half, and we see that the area between z=2 and z=3 is 2.35% of the total area under the curve. Now we can do this for all of the different slivers of our normal distribution, but I think this gives you enough information that you can fill in the rest yourself.